everyone. Sorry I couldn't be there in person, but I already know that my classmates have done a very good job. I'm going to run you through a case study that very much links to zoonotic diseases, but it's not so widely spoken about within global health and development. So we all know kind of the 101 of climate change is that when the planet gets warmer, that obviously there's more melting of ice, sea level rises, and often because we're in these circles speaking about climate change all the time, we forget that it's important to think of the basic science, and it's something I want to draw your attention back to in this case, because it's not just about the ice melting and sea level rising, but it's also about what's underneath the ice, and that's something that's been very widely neglected until the last decade or 2 decades, especially in the global north. So let me take you on to the next slide. What could actually be underneath the permafrost? So we already know that there's mass graves of both people and animals, and all this sounds very dramatic and Hollywood movie-like, imagining like the thawing of ice, the melting of ice and the thawing of permafrost. This is actually just very normal. Permafrost itself can be different matters. It's not like we imagine always ice melting, but it could be sand, different forms of silt, mud, clay. It really is just any kind of earthly matter that freezes and then can thaw over time. And obviously, when things die, humans have a tendency to bury them to protect ourselves from pathogens, and also as a cultural process. But obviously, if there's more and more increasing rising temperatures, and things are thawing and also the ice is melting, then some of the things that previously we thought would not emerge again are emerging. That brings me on to, if I move myself for a second, this 100-year-old penguin that was previously under ice. You can see that after all that time, it was preserved, let's not say perfectly, but we can still see what the animal was originally. And this just really goes to show the power of these very low temperatures and how it really manages to preserve things, which is very important when we think about zoonotic disease, as you'll see now on the next slide. So, to move myself once more, what is the actual process and why is the health threat not more widely spoken about? And this is obviously why we took the topic as a group. Essentially, as I mentioned, as temperatures are increasing, the permafrost, which is again these different layers of silt, earth, clay, etc., they begin to thaw. And when the thawing happens, it's not just things that are emerging over time, and it's able to be exposed through abrasion and different processes, but actually the pathogens are activated which were previously dormant, and this is obviously the big fear, especially after the COVID-19 pandemic, of what could actually be underneath the ice and what's perhaps preserved. And when we think of that penguin, we can see that it's still looks like a penguin. So what are the diseases that maybe it carried before? What pathogens could it contain? And this is very much the fear. And when permafrost is warmed by the sun, by rising temperatures, it's not only activating these pathogens, but they're able to work their way up to the surface. It's part of the living organism. They're wanting to find another host. And it's just the natural process and the way things work. So we move on to the next slide, if it works. This brings me on to, if I move myself up a little bit into this corner, what is actually the threat to people and to global health. And as Martina already mentioned, we have planetary health, and we think about the relationship between Earth and people, but also there's the animal kingdom to think about and how we're actually all interconnected. So maybe Martina and Pradeep can pause me for a second and we can have a little comparison as a class to what the differences between planetary health and One Health are. And as that was part of our university readings and was mentioned in the lecture, do we think that one is better? Maybe we can discuss that for like 30-40 seconds. I can be paused and then we can continue. So pause in time. And hopefully I have been unpaused at this point. Um, I don't think there is really a right answer if one health or planetary health is more important. I guess it's really the way we use those tools. But in this case, it's very important when we're thinking of permafrost thawing and the pathogens that could potentially be released, because scientists so far do not think the pathogens that would be exposed and activated again would be necessarily a threat to humans. However, they are very much a threat to the animal kingdom, because when they're working their way up towards the surface, they are usually taken away with water runoff, especially from ice that has been melting as well. Usually ice is near these permafrost areas, and they enter the waterways, and this works its way up the food chain. Yeah, we as scientists, the community does not really know yet how far up this could go, and also what the threat is to humans. But if we go into the next slide, it's interesting to maybe look at a case study. If you quickly look at this dead reindeer, I'll move myself over on top of it for a second. There was a very famous case study which really did shake the world, where an anthrax outbreak happened in Siberia in 2016 during summer, where there was a heat wave and it was abnormally hot, and it meant that permafrost, which usually thaws naturally as part of the summer, but not so deep, was allowed to be exposed to the sun for a lot longer time. And this obviously allowed these pathogens to awaken again, to move to the surface, and it actually led to a lot of reindeer deaths. So it's very common to have reindeer cattle there, and due to unknown reasons, or it's kind of still debated a little bit within the literature, but obviously some exposure, a 12-year-old boy actually died as well. So this is a case, again, if we're thinking of One Health, where the natural environment, animal kingdom really did impact people, even though it wasn't such a mass zombie apocalypse that was perhaps displayed in the video by Pradeep, or this kind of dramatic Hollywood view of disease outbreaks, especially zoonotic disease outbreaks. Yeah, so this was one very famous study. There have been a few others. This is usually the most cited by scientific literature that I could find within permafrost. If you move on to the next slide. What's also very interesting about the idea of these pathogens that could be lying dormant and not knowing is what they could also be used for. So here, bioweapons is the obvious one. There have been cases of bioweapons being used as a form of terrorism, and obviously since 9/11 the fear and the threat has seemed much greater. It's also interesting to note that Russia was very much at the forefront of doing research on permafrost and the bacteria below, and obviously if you're coming from a US or global northern perspective, or Western perspective, especially in this case, and what's going on with Russia, Ukraine, etc. This is obviously something that's perhaps become more relevant, and potentially what results they've found, and what zoonotic diseases could potentially be used against other nations. And in addition to that, there's also an increasing body of literature that shows not only bacteria that's exposed to antibiotics is becoming resistant. However, it's also areas that are very isolated, that in this case, ice-dwelling microbes have been shown to have the ability to actually also resist antibiotics. And this is very scary for global health practitioners, because we don't know the future, and we don't know at what point the resistance will mean that the medication that we have is not sufficient. And obviously a lot more research needs to be done into that. But let's not end on a doom and gloom note. Let's think about some solutions. And as was kind of the case for this presentation, we wanted to think a little bit outside of the box, and not just the very obvious global health SDG related goals. So here I've put target number 17, partnerships for the goals, as the focus, with good health and well-being, climate action, life on land, peace, justice and strong institutions, and life below water, all going under the umbrella of this. here I've also put some suggestions: reducing and halting, reversing climate change. There are amazing climate scientists doing groundbreaking work, and we all know the urgency behind that. And I think, at least I can speak for myself, I think the discussion around how global health fits into the picture has been very interesting to learn about. Um, Reducing the amount of antibiotics that are given, especially unnecessarily, and the disposal of those antibiotics, and also just doing more research, more funding into taking samples of pathogens that are entering these waterways and figuring out what's going on. So I will pass on to my colleagues to explain the next task, which very much links to these SDGs that I've just listed. And I'm very excited to hear back what they report from the discussions.